Assalamu alaikum. Welcome to Fire Automation's YouTube channel. We are here to learn another PLC programming example. In that example, we will also use Beauty instructions to solve this. And actually, this is a real life problem, and we will try to solve that problem. We will also use addressing and tagging so that it can more understandable for human. And we will also use interlocking concept. And let's see that problem. Actually, this is the stair system, and we have to implement the lighting system in stairs. First, while getting into that, let's imagine we have only one switch and one lamp. When we have to go from bottom to top, then we will press that button and the light will be on. But when we will reach at the top, we will not be able to switch off the light. But we want to switch off that lamp so that it cannot consume more energy. The solution for that system is that we have to implement two button R2 switch. It can be implemented in circuits, but we are here to explain in PLC programming. We will implement the ladder logic programming of that system. Here is two inputs of that system, x0 and x1, and one is output y0. Here you can see that x0 is input 1, x1 is input 2, and y0 is our output. Let's implement this in TI portal. I have already opened the TI portal. Let's implement that logic. First we will design simple logic. Let's take a normal open contact and the output coil. We can name it as 0.0, and this we can say it Q0.0. We can tag it as a rename tag. We can say it, this is our input 1 and this input 1 is x0. Okay, and the output is our lamp. We can tag it as y0. Okay, let's download this. Load this. No, it has been downloaded. No, on the metering mode. First we have implemented only simple logic on off logic. In that case, when we will press this button, our output will be on. But you can see here, when we press this x0, this will be on, but we will not be able to switch off that lamp when we reached at the top. That's why we have to implement another logic. Let's drag and drop another contact, and we can name it as m0.1 and tag it as x1. What we want from that logic? Actually, we want that when we press that button, the output coil should be on. It means we have to implement and this x1 and normally close contact, so that when we press this, and this should be on. If we implement the normal open contact, then the output will not be on. That's why we have to implement the normally close contact. So in that condition, when we will press x0, the output will be on, but when we will press x1, the output will be off. Let's download this, load this. It has been downloaded. No, on the metro mode. First, when we press that button, this is x0 and this is x1. You can see here that this is x0 and this is x1. When we press x0, light should be on, and when we press x1, it should be off. Let's modify this as 1. You can see that when x0 is 1, the output is 1. It means our lamp is on. When we will press x1 button, our output should be off. You can see here our output is off, our lamp is off in that condition. Now this logic is implemented, but here there is another problem. We can see it. Another problem is that when first person is reached at the top, okay, another person wants to go from bottom to top, then what will be logic? Is this logic will be valid for that one? No, this logic will not be valid for that one. Then what we have to improve? You can see first we will see that how this logic will not be valid when the first person is reached at the top. Okay, then it means x0 is 1 and x1 is also 1. Okay, you can see it here. Okay, in that condition, when first person is reached at the top, the x0 is 1 and x1 is 1. When another person comes from bottom, he will press x0. Okay, when he will press x0, he will toggle it from 1 to 0. Okay, when he will toggle from 1 to 0, our light will not be on. It means this is the problem. Then what we have to implement in that logic? And then again we modify this as 1 as first person is reached at the top. Now we will modify this logic. We will another branch and drag and drop this one and another contact and connect this, and we will name it as m0.0 and this one m0.1. We will see that why I have implemented there. In that condition, when another person will come, when another person will come, he will press x0. Okay, it means when he will press x0, the light should be on. But as we know, when first person is reached at the top, this is already 1. Then what we have to implement that logic, what we have to improve? It means we have to we can say that it should be in normally closed contact, because when he will toggle from 1 to 0, that means it should be on. When he will toggle from 1 to 0, in normally closed contact will be on. As we know, x1 is already 1. Okay, you know that we see here, and you know that when first person is reached at the top, x0 will be 1 and x7 will also be 1. Okay, but when another person will come, he will press that one. It means when he will press, it should be on it, where, and that's why I have implemented normally close contact. When he will press that one, this will be on, and this is already 1, then the output will be on. First download this, load this, and on the monitoring mode. What is our previous condition? In previous condition, x0 is 1 and x1 is also 1. First person is reached at the top. Then consider another condition. Another person wants to go from bottom to top. What he will do? He will toggle x0. Okay, he will toggle x0. You can toggle it from here or here. I am toggling it from here. X0. As you know, x0 is 1. We will toggle it from 1 to 0. Now you can see that when a second person will come, he will press x0 and the light will be on. Then what is another condition? When he will reach at the top, he will face x1 button, x1 switch, then he will press x1. He will toggle x1. You know that x1 is 1 in that condition because first person has reached at the top and second person is also reached at the top and he had not pressed x1 yet. Then he will press x1 and this is 1, then we will toggle it from 1 to 0. Yes, now you can see that when second person will reach at the top, he will press x1 and the light will be off in that condition. Now you can imagine another condition for third person also. When third person will come, he will toggle that one x0 from 0 to 1. When he will press x0, the light will be on, and when he will toggle this as 1, the light will be off. You can imagine many more conditions as well. And now this logic is valid. Now we will consider the a condition when any person wants to go from top to bottom. Then what will be the logic and what will be the output? Any person wants to go from top to bottom. Then he will face x1 switch. He will toggle x1. As you know, x1 is 1, then we will toggle it from 1 to 0. No, you can say that when he will press x1, the light will be on, and when he will reach at the bottom, he will press x0 and the light should be off. Now you can see that and light is off in that condition. You can also imagine another condition. Now we will see that how interlocking concept is implemented. What is interlocking concept actually? The interlocking concept is that when one input is pressed, then he will face another input also. It means our first input will depend on second input. This is the interlocking concept. When any input will depend on another input, this is the interlocking concept. It means when we will on the switch, then there is no surety that it will on the switch, and the other input will also be considered, that what is the condition of that input. Actually, this is interlocking concept. I think you really enjoyed this video. If there are questions or suggestions, you can tell me in the comment box. If this video enhances a bit of your knowledge, you can like this video. If you haven't subscribed this channel, please make sure to subscribe this channel. Thank you very much. Allah Hafiz.